Hi, welcome to another episode of PX and the Art of Programming. Today I want to start off with an improvement that I made to the text below this video. The context box, description box, that's the official term. I have added 3 book titles for further reading. The first one is Writing Solid Code, written by Steve Maguire, and it's published by Microsoft Press. The other one is Literate Programming, a book written by Donald E. Knuth. And the last one is An Introduction to Database Systems. And the later one has 2 volumes. Let me improve that in my text. Volumes 1 and 2. By C.J. Date. And if I'm correct, then C.J. Date worked for IBM. Donald E. Knuth, he worked for universities, not for commercial firms, I believe. And Steve Maguire, I assume he worked for Microsoft. The first one is probably the most interesting one if you are planning to start a career as a computer programmer. Your code has to be solid as a rock. And this requires only 3 things, namely discipline most of the time, and discipline all the time. So it's easy to remember, it's discipline. 3 times over. And the second one, Literate Programming by Donald E. Knuth. In Holland we would say Donald E. Knuth. And Knuth, it's not it's not a word standing for something good, but Knuth. It should go. Literate programming is a technique to make your program look like a book, to make it readable like a book. And I admire his effort. And I am not using his technique at the moment, I should add. But still, the fact that a program is primarily meant for a human to be readable is the main goal of the programmer. You write software and your main audience is not a bunch of CPUs, but it is a bunch of humans. It should be understandable by humans. You should program for humans. So it's a dichotomy. On the one hand, you are programming to instruct, to inform a CPU, a central processing unit, a language machine. And on the other hand, you are trying to inform the technician who wants to read and understand your code because he wants to extend it. Or maybe he is using your code and the code does not behave like he expects and he wants to know why. Your code has to be understandable. And the last one, An Introduction to Database Systems, Volume 1 and 2. I added this book, these two books. I have them both. Literate Programming, I have a copy also. And Writing Solid Code, I gave my copy away after I understood the content of the book. And of course, I did not get it back. That's how it happens with books. But Writing Solid Code by Steve Maguire, what is the price nowadays? It's, well, $35. Quite a lot. But maybe a second hand? Used. How was it used? Oh. Even... Oh, a paperback version is $19. Oh, and 95 used from $1.25. Well, that's doable, don't it? Doesn't it? The other ones must be more expensive. Literate Programming by Donald E. Knuth is quite expensive. It's a lovely book. And an introduction to database systems is, well, the message is short, namely every table needs a primary key, and the primary key is used to reference within the database a record of another table. But it's a good practice for your brain to study the two volumes. Right. Back to program. I'll back up because databases is all what it is about when writing computer software. And it has to do with the fact that a program handles data, and data has a structure. And therefore, a structured data is called a database. A database is nothing more, nothing less than a structured set of data. And an information system, therefore, is a computer system, is a program, and every program handles data. Right. I have prepared a little demo. This is the software that this is the system I wrote for my friend Wim. And he makes a lot of films, videos of live bands here in Arnhem. These are the last uploads he did. And the software itself does not store the binaries of the movies, but only the links to YouTube. So I can click on one of these, but it's just a YouTube link, embedded YouTube. Let me take an example. Amsterdam Klezmer Band. Klezmer is Jewish music. And then the videos of this band appear. And here is a search box, and if I type in VIER, then the name of my band appears, Vierman Sterk. And that's me to the right. That's it. So you might call this minimalistic. And it contains all the info needed. Everything Wim needed for the presentation of his life's work. Well, now let's have a look at the back end. And this is the screen that Wim works in. This is the logo itself, but now it's a bit smaller because we are not interested in having a nice outlook, just maintaining the data. Here we have the movies, and here you can see we have 1001 lines This is Dutch, the language is Dutch. You can switch it to English and then it would say 1001 lines. And here are the pages. This is page 1, page 2, page 3, page 26. This is the one with an ID of 2, meaning it's one of the first videos ever entered. And it's a video of my band. I entered this record, namely, just for testing. And here you can see the contents of the table underlying this database. One of the tables. The idea is the primary key of this table. The date is the date of the recording. The performer is what we call a foreign key, and it denotes to the band Vier Man Sterk. If I click on it, then the band Vier Man Sterk will appear, and below the band are all the videos inserted under the name of this band, under the primary key of this band. The location is also a foreign key. There are multiple locations. And these are all the videos, films in Dutch, recorded under this location. The videographer is only 2hands2. That's the screen name of Wim. Here we have a text field with the YouTube embed info. This is a field, it's calculated by the system itself to produce a standard, what we call our standard pixel size of one video. Wim gave me the dimensions of what he wanted to see as a, you call it a thumb of the video. And then the description, and the description can be multiple lines. Well, let me edit this entry. You can see that the entry here is multiple lines. Other stuff. This, what the functionality that you see now, I did not need to program. It's all built in. Because there's no need to reprogram this. This is so plain, so obvious, that it should be generic code producing this interface. Well, what you are looking at now is what is called a tuple. And a tuple is nothing more, let me get OpenOffice to it. A tuple is nothing more than a row in a table. This is called a tuple. It's one line in the table. This, the column A, it's called an attribute or a field. And this is also called a record. So tuple and record are pseudonyms. And a field or a column or an attribute are pseudonyms. And a table, in this case the whole table, is also called an entity, just for the naming of stuff. Well, this is a tuple, and this tuple only has 1, 2, 3, 4, 5, 6, 7, 8 attributes. But some tuples have a lot of entities. Let me get a good example. Give me a second. This one. Oh, it's empty. Anyway, it's a table to store real life persons and companies and foundations. And this table, these kinds of tables, have lots of tuples. Let me try to insert one. The name of the company, if it's a company, I can switch to, it's a person, a natural person, then I have a last name, first names, prefix, whether it's a male or female, it's Dutch. The address, it's all fields. And this table is a wide table in the sense that it has a lot of columns. Now, this creates a problem of performance. If we go back to this table, the data that you see at this moment, 1022, 0408, 2019, this data is stored in one structure, and it's called a tuple. And the tuple has attributes associated to it with these names. And I want to be able to get to the content of a specific attribute of the tuple in a fast way. Like immediate. And the first way to get to the content of a certain attribute is to supply the internal name of the attribute. And if I click on the field name, then a rather ugly screen will appear, and it will tell you that the internal name of this attribute is this piece of text. I will copy it. And I will go to Text Wrangler, my favorite text editor. Please buy the full version, and it's called Bare Bones BB Edit. But Text Wrangler is for free. And this is the definition of the table, of the field. And the internal name is Synergy YouTube Archive Movie _ embed _ small. It's the small version of the YouTube embed text. And here you can see the name as the user will experience this field. But I'm considered with this name. You can imagine that in a piece of program, you will use this name to address the content in a tuple of the field. Still with me? You only have the name, the internal name, SYTAMOV _ embed, or embed small, one of the two. And you want to see the content. What you don't want is that the tuple will look at the first attribute and say, it's not this one. Then look at the second attribute, it's not this one. Then it will have to step through all the attributes. This is, of course, no problem concerning the entity videos or movies. There only are maybe 10 attributes in the long run. But if we have a table like relations with information of peoples in it, then we can speak about maybe 100 attributes. And then performance will kick in as a problem. So the other way to go is to have a table of sorted attributes, sorted columns, sorted by alphabet on the name, or sorted by the address of the object, because fields are stored as an object. And then you can try a binary search. You just pick halfway of the list. Did you pick too high? Then you pick on 1/4. Did you pick too high? Then you take a new pick on 1/8. It's called a binary search. But binary searches are not the maximum speed searches. The maximum speed is delivered by hashing tables. And in the last episode of PX and the Art of Programming, episode 006, let me get my YouTube channel in the picture. This one, PX006, The Art of Programming, a summary and a look into px2 index. And I have discussed the content of this structure, px2 index. This I have programmed about more than 10 years ago, maybe 14 years ago. And I am busy streamlining the source code. I have time for that. It's a whole different subject, but I've managed to create lots of time for myself to streamline the code. And decided to rewrite this and to create a new object much leaner, and therefore leaner, smaller, meaner, faster. And I promised it in the episodes in which I discussed the content of px2 index. Some nasty, for instance, this function. Where is it? It's defined here. I think yes, that's the one. This inline function is it's a no good. So, meaning no good, meaning too complicated, too many functionalities in one piece of code. You can listen to the other episode, and then there I will discuss this function and the use of it, and then compare it to what I have written as an answer to my own critique on my own code. First of all, I set up a new structure and I named it px2hashtable. I will use a hashing function to store a tag, a piece of text, to a 64-bit number. And a 64-bit number can also be used to store an address on a 64-bit machine, don't it? So whether I store a number or an object, it can be stored in this hash table. And I store the number under a, for humans, there once again, for humans, a readable piece of text. Now, in this episode, I will talk about how I implemented it, what I did first, what I did second, and how it works. First of all, I set up test software. And as you can see, this function test underscore px2hashtable is a function or method of the singleton px2g. And the singleton is an object, is a class of which only one object resides in the system. I only have one singleton in px, it's called px2g. And G stands for global, and in this case px2 because it's the global defined at level 2. And I have explained in earlier episodes that px is made out of levels. Level 0 is over here, level 1 over there. Now we are busy at level 2. And this is the definition of the singleton at level 2. And the singleton at level 2 has a lot of testing functions. First one is named test. And these are all sub-functions of test. Functions that test will call. And one of these tests is test px2hashtable. And let me look up where it is called. It's called over here. Execute execute the test px2hashtable. I will set the breakpoint and I will start the system. And since I have stated that this variable in px.myparams.text, this variable run test of parameter, run test at startup has gotten the value 1. It will dive into the test software. Now it stopped at my breakpoint with tx2 so test px2hashtable. I will step into this code. And the first thing that I am testing is the working of the working of the translation of a character to a hash value. And I am not quite happy with the name hash value, because normally a hash value can produce the same value, the same hashed value, for different inputs. And in this paradigm, in this way of thinking, no two identifiers can have the same hash value. For instance, the hash value for capital A, with the value 10, equals the hash value of lowercase a. That's a decision. Huh? And in the px style of programming, there is no difference between a variable or parameter written in uppercase and the same name written in lowercase. They are considered the same, and lowercase is advised. Don't use uppercase, never know, never need. Never not. And the reason for that is that lowercase is easier to read, and we program so that humans can easily read the software. For a computer, it doesn't matter if you use uppercase or lowercase, but for your human reader, it matters. Lowercase is easier to read. Because lowercase, I will explain this just by sidestepping to OpenOffice. Let me get a textual document. I will switch over to some kind of monospace font, Courier. and extra large, well, even larger. It took the, sorry, it took the font info with it. Because I copied it right away from Xcode. This is what I meant. A bit smaller. Even smaller. Yeah, this is the one. Here you can see that the H is higher than the A. Huh? So you have a pattern here. Your eyes, when they read, they do pattern spotting. So this word hash has two relatively long letters at the start and at the end, and in between letters of the same height. If I compare it to this, has G value from char, then your mind's eye will see the difference quite easily between hash with an H in the end and has G with a G at the end, because G has the same height as an H, but it goes below the line. If, on the other hand, I work with pure uppercase, then this distinction is lost. You get? Well, this is the reason why a computer program should be written in lowercase. Discussion closed. Discussion is over. It's now 17th of August 17, 2019. The discussion is over. And you might argue, well, but people from Apple Computer Incorporated, they use Camelback. So the function hash value from char would be written like, in a Camelback, it would be written like hash capital V, capital F, capital C. Yeah? It's called Camelback. Now, I call it fancy typing. It's not what I like to type. Even if you do touch typing, still typing a capital V, an uppercase V, is more work than to type a lowercase v. Therefore, lowercase it is. And if you want to make the distinction between hash value from char, and you want to make it clear that in this case hash value from char, I can read it in one time, but in one glow, but you can add an underscore if you would like. We will see an example of that in a couple of minutes. Radio video, back to the programming. First I set up this testing code, and then I start to program. That's the other rule of programming. First you write test code, you incorporate your test code into the big testing scheme, meaning that the test will fail if you do not finish your programming job. For instance, I'm going to expand the next step that I'm going to write will be a delete action. Then the first thing that I do is I write up the code, I write down the code like delete or remove something like this. That's the first step that I take. And then the test software will fail because this won't even compile at the moment. But if I implement the remove function, then compiling will go fine, linking will go fine, but the test will fail because it's not implemented correctly. So first you start with writing test code. Now you have looked into the test code which tests the hashing function, which is not really a hashing function because it only will come with unique hashing values. Because, and how did we do this? We only allow numeric values from 0 to 9, letters from A to Z, also uppercase, but they are considered equal, and some special characters like the underscore, the hash sign itself, the dollar sign, the ampersand, the hyphen, the dot, and for the rest, nothing is accepted. And this will leave us with, in total, 10 plus 26 plus 12 different hash values for any character in an identifier. Agreed? Now, how does the hashing function work? Here it is. I'll break away. So, I have implemented it as an inline function, meaning that calling this function will not result in a stack procedure, in pushing a return value on a stack. You should be familiar with that thing. I'm not going to explain it now, but if you call a function, then a stack operation, normally a stack operation will take place, and I don't want it, because I want this to be very fast, ultimately fast. And the function is very simple. It takes an unsigned byte, unsigned character, pxb byte, and it returns an unsigned char, a px byte, pxb. The first thing it starts with is a px OK always, and there it is checked that the character is bigger than a space, meaning identifiers may not contain spaces, and they may not contain stuff like the character null or nil, or a carriage return, or a tab, or what do you call it, an ACK or a NAC, all the control characters, no goes. And if this function is called with, for instance, a space or a Control-C or whatever, then this macro will stop the execution of the function and give this return value. Definition within px d px b for byte max. And let us look up the value of dpxb max. You can guess it. It is, of course, -1. Agreed? Now, then we do the real translation stuff. If the character is in between 0 and 9, then the return value is the ASCII value of the character minus the ASCII value of 0. And the same for A to Z, the same for A to Z when talking capitals. So a hash value of 0 refers to the character 0. A hash value of 9 refers to the value of 9. A hash value of 10 refers to the character A. And whether it refers to a lowercase a or an uppercase a, that you won't know. That's information that is lost. That's no problem. And then we have some special characters that we want to attend. And this list is not complete, but for now it will do. And the reason it is not complete, to my opinion, is that I have decided to use 48 different hashed values. So I fill up 6 groups of 8 bytes. There's no need to fill 5.5 group of 8 bytes. Then you can just as well fill up 6 groups and have some advantage from that. It also means that the maximum hash value is 47. Agreed? 10 plus 26 plus 12 is 48. But we start with a 0. So the max value is 47. So the name of this macro, dpx hash value max, is not correct. It should be dpx hash value max plus 1. Huh? But we leave that plus 1 out. All through px. It has something to do that within the language C, all the arrays, all the first elements of an array are element number 1. So 1 is 0, no, 0 is 1, 1 is 2, 2 is 3. Therefore, dpx hash value max. Naming convention. Now back to the test code. The hash value of character 0 is 0. The hash value of character 1 is 1. And the hash value of the character underscore is 36, and so on. Right. Now you can agree with me that the implementation that I have written is cannot be improved. This is perfect code. If you limit the code to the functionality that it has to provide. It only has to translate a single character to a hash value. And it does some compression, of course, with the A to Z. That's all by definition. Furthermore, what it does is if this function is given a character that does not occur in this list of characters, this collection, this set of characters, then it will run into the px always 0. That's a trick, meaning px always not. So this will fail always. And then the value that is returned is again the value equal to -1. 255 for an unsigned character. And since this macro will fail, will return the error value, this will produce an entry in the error log also. Right, back to the test code. I'm a bit through my time, I see. But I will fill this up to 1 hour, yeah? Now maybe I should call it a day for this broadcast. Now, we started it just one step further. Here I declare a variable, my hash table, of type px2hashtable. And here I will do a find operation in this hash table for a number stored under the tag A. And this should, of course, fail. Don't you agree? Because the table is empty. Now, the function find has 3 parameters, namely the tag to find, a pointer to a boolean, to a byte, which is empty. It should be empty. And a pointer to a number, and this number should also be empty. And the result of this function should be that the boolean, the byte, still is empty, not found, meaning, and the number is still empty. Right, I will discuss only this piece of test code. And in the next hour, I will discuss test code 1, 2, and 3. I think, yeah. Right. Let me break here. And now we will step into the constructor. Here we are. Oh, my bad. I'm sorry. Hit the wrong button. Step into px2hashtable. Well, you might recognize this as a normal C++ class definition. The name of the class twice with the double columns in between. Then we have 2 parameters, and those were left empty here. And this is allowed because these parameters have a default value. Let me switch over. The default values are 0. And this object, px2hashtable, is based on the class px1 object. And the class px1 object only has one goal, namely to watch out for memory leaks. So every object that is created, it is seen to it that the created objects are all deleted. One by one. So not most of the objects are deleted when the program terminates. No, all of them. And objects can be stored in 3 ways, namely as an object in the structure, in a structure, or an object on the stack. And this object, for instance, in the test code, yeah, over here. This object here is stored on the stack. You agree? It's a local variable. So I don't have to mind on deleting this object, because this object will delete, the system, C++, will delete this object when the scope of the variable terminates. And it will terminate with this accolade right. Huh? So, and I have defined a macro, it's called dpx storage heap or stack. And it should be called dpx storage heap or stack based on the fact if we are debugging. But if you want to see the definition, it's over here. dpx storage heap or stack. Under debug, it is considered a heap storage. And if not under debug, it's considered a stack storage. And the reason for this is that objects that are created on the heap, they get extra attention. They are guarded extra. Because objects that are defined on the stack, they will dispose itself. Still, we have to guard them. But the risk that these objects will remain alive when software has terminated is ultimately smaller. Well, what do we do when we want to create a new hash table? Well, the first thing that we do is we test the interface. A hash table only is responsible for the first character of the tag. So if an object, a number is stored under a tag of 3 characters, A, B, C, then 3 hash tables will be alive. Now, the first hash table will contain the reference to the second table, and the second table will contain a reference to the third table, and the third table will contain the actual data. Yeah, you see this picture in front of your mind's eye? So a hash table can have an owner, and if it has an owner, then the hash table has an index within the owner. If a hash table is within an owner hash table, if the hash table is the hash table for the character B, then the index should be 11, since the hashed value of B is 11. It's recursive programming. It's hard to get the picture in your mind, but just try it. Huh? Now let's have a look at the header file again. This is the constructor method. This is the method which will check the integrity. This is the method for adding and finding. This is another method I will discuss in the next hour. And here it's all about, it's a dummy declaration. It's called it's debug electric fence start and it's debug electric fence end. And in between these two variables, an array is defined. And this contains the pointers to the underlying hash tables. And at first, this array will contain only zeros. But if this hash table has some data, it is an endpoint of a number which is stored in the hash table, then this variable will have the value 1. And here you can see the usage of the underscore in the naming of variables. Well, it's data avail as one term. It's hard to read. Data avail. Or with a underscore in between, it's data underscore avail. It's good to read. And this is the actual data. And this is a pointer to the owner array. And this is the index within the owner array of this array. It's recursive software. It's just like those Russian dolls. Well, in the initialization, we put in the electric fence, and this name, it is a fence, and the electric fence start contains a sequence of ones, binary 1, and the electric fence end also a sequence of binary 1s. This is all to to detect writing outside of this array. This is unprotected. There is a structure in PX that you can use to set up an array with protections built in, but these are this will cost you performance, and I chose to have no performance, all to denote everything for the performance. Hence, under debug, an electric fence. And the word electric fence I learned from a utility that you can install when you write C software to protect your memory and to protect yourself from writing outside the bounds of your allocated memory. This utility was called electric fence. I don't know if it is still around, but in those days. And this is what it did. A marker before, at the start, and a marker at the end. Now, its data avail is cleared at first. Its data is 0. And if there is an owner, then, if there's no owner, then the debugging software is, I skipped this. If there is an owner, then the owner should be a valid object. And the index should be smaller than px hash value max. And px hash value max should read as dpx hash value max plus 1. But we leave out the plus 1. And the index should be smaller than that. And if there is not an owner, then there should not be an index. Don't you agree? No owner, no index within the owner. Now you can argue whether or not you should take these lines outside of the if statement and write if the owner, its owner becomes the owner. I decided not to do that because this will take up less. It's two lesser assignments. Well, its owner becomes the owner, its index becomes the index. Then under debug, we assume that our spot within the hash tables of the owner is still empty. px OK always. This should be the case. And we write our own address in this array of the owner. And last, we perform a check integrity. Check, 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 and double check. What do we do upon the delete? Well, apart from running a check on the integrity of our cells, we loop through the array of hash tables, and if a certain entry is empty, then we'll step to the next one. If it is not empty, then we check that it is a valid object. Then we delete this object, and then we check that the location within the array is now empty. Here it is filled, pix valid, its hash tables at index, and here the value is empty. And that is all because the last step is if this array was defined within an owner, then the hash tables of the owner at our index is cleared. So in this way we guarantee that all the hash tables connected to a certain hash table are deleted upon delete of the main index, on the main hash table. Almost ready for this episode on the hash table. I will write a piece of code. It's interesting for you guys also. After declaring, after declaring the object hash table, then I'm messing things up. It should be this. After declaring the hash table, the current object count, a function of the singleton G2, should be equal to the object count at start. It's over here, huh? Plus 1. Don't you agree? And after the scope of the variable my hash table ends, this accolade right, then it should be back to the number of objects at the start. Right. Let's see if this all holds. It does some compilation right now. I don't know if you can see that. Lovely product, Xcode. This is the creation of the hash table. Step over it. The object count should be one more than the count at start. Yeah, that's okay. Then the find, I will skip it due to the time reason. And after the scope of this local variable has ended, the object count should be equal to the object count at start. Hence, the software works. Thank you very much for listening to this episode about hashing tables. And I will see you at the next episode concerning hash tables. And I will go into the phenomenon of adding a number under a tag, later to be a field name, parameter name, variable name, in a hash table. And the blazing speed of looking things up. Thank you very much for listening and see you next time.